Hi, we're going to skip a couple of sections and go to solving a system of three equations which have three different variables. So when we get a solution, we'll have an x-coordinate, a y-coordinate, and a z-coordinate. We call that XYZ an ordered triplet, and it's a solution of a system of three equations with three unknowns. Now we're actually dealing with planes, and we're not going to graph planes because that's really difficult to do. But I want to point out that the planes can intersect in three ways. There can be no points in common, and that happens in a variety of ways. We'll look at pictures, illustrations in class tomorrow. That's inconsistent when you have no points. That's inconsistent. Then you could intersect in one single point or an ordered triplet. X, Y, Z. We call that consistent independent. And then we have an infinite number of points where actually the intersection is actually a complete line, okay, and that's consistent dependent. So again, we're going to look at illustrations of what those scenarios look like in class tomorrow. There's pictures in our textbook that we're going to look at. This is some big picture steps to go through when you are solving a system of three equations with three variables. We're going to do several eliminations, and then we're going to do several substitutions. So step one, we're going to use two equations, and we're going to eliminate a variable, any letter. We're just going to eliminate, okay? Then we're going to pick two more equations. So one of them will repeat, okay, and eliminate the same letter. The key is the same letter as you did in the first elimination. Okay, so now we've done two eliminations. Now we're going to take that two equations with two variables, and then we're going to eliminate again, leaving us just one variable that we can solve for. Once we solve for that value, we're going to substitute it back into one of our two variable equations and solve for the second variable. And then we're going to take those two values and we're going to plug it into an original equation and solve for the third variable. We're just going to quickly check our answer and then classify the system. Okay? All right, so here we go. I am going to take equation, notice that I call them equation 1, equation 2, equation 3, okay? That's just to help me explain what I'm doing, all right? If it helps you to use that, that's fine. If it doesn't help you, then you don't have to use it, but I'm going to use it to help explain what I'm doing. In this first example, I'm going to take equation 1, I'm not going to change anything on that one. And so I get 3x minus 2y plus 4z is equal to 35. And then I'm going to multiply equation 2 by the number 2, and then I'm going to add it together, negative 8x plus 2y. By doing that, my y's will drop out. Minus 10z is equal to negative 72. And now I'm going to add those together. And I get negative 5x minus 6z is equal to negative 37. That's one elimination. Now I'm going to take 3 times equation 2. So I'm going to go 3 times equation 2 because I want to drop out my y's again. 3 times equation 2. I get negative 12x plus 3y minus 15z is equal to negative 108. I went 3 times equation 2. And I'm going to add it to equation 3. And that leaves me 5x minus 3y. Notice that now my y's will cancel. Plus 3z equals 31. And I'm going to add those two together. So I get negative 7x, these cancel, minus 12z is equal to negative 77. Now what I'm going to do is I'm going to label this equation as equation A. And I'm going to label this equation as equation B. All right? And with these two equations, I'm going to eliminate the z's. And I'm going to do that by going to negative 2 times equation A. That gives me positive 10x plus 12z equals positive 74. And now I'm going to add it to equation B. Negative 7x minus 12z is equal to negative 77. So now this was my first elimination, this was my second elimination, this is my third elimination. Okay? And I eliminated the z's here, so I have 3x is equal to negative 3, and then x is equal to negative 1. Now I'm going to go to the next slide so I have more room, and it's blank, left blank for you, so that I can show you now. I'm going to start substituting back in. All right. So I'm going to take x equals negative 1. And I'm going to substitute it into my equation A. My equation A was negative 5x minus 6z is equal to negative 37. Now I'm going to plug in the negative 1 for x. So I have negative 5 times negative 1 minus 6z equals negative 37. So this is 5 minus 6z is equal to negative 37. So negative 6z equals negative 42. Z equals 7. Now I have a value for x. This is my value for x, and I have a value for z. And I'm going to go ahead and I'm going to plug those into substitute x equals negative 1 and z equals 7 into, you can pick any of them. I'm going to pick equation 1. Equation 1. So my equation 1 is 3x minus 2y plus 4z equals 35. So I have 3 times negative 1 minus 2y plus 4 times 7 is equal to 35. This gives me negative 2y plus 25. This is 28. Minus 3 gives me positive 25. Negative 2y equals 10, and y equals negative 5. So my solution is negative 1, negative 5, and 7. Okay, negative 1, negative 5, and 7. And that's going to be consistent, independent. Consistent, independent. Now I'm going to show you one what it looks like with a three variable system when everything drops out and you're left with either an inconsistent or a consistent dependent. I'm going to do one of each, all right? So in this system, again, this is just how I label them, equation 1, equation 2, and equation 3. I am going to eliminate z, and I'm going to multiply 3 times equation 1, which is going to give me negative 12x minus 6y minus 3z equals 45. And then I'm going to add it to equation 2, which is 12x plus 6y plus 3z equals 45. And notice that I get these all cancel, 0, but this one adds together equals 90. This is never true, so there are no solutions and inconsistent. This last example, I'm going to show you what it looks like when you have an infinite number of solutions. All right. So in this one, I am going to eliminate my x's. I've just decided to eliminate my x's. So I'm going to take equation 1. I'm going to rewrite it. Being organized in this is so important because if you make a mistake early on, you're gonna do a lot of work and it's gonna mess you up. And then we're gonna go minus 2. We're gonna do negative 2 times equation 2. So I get negative 2x minus 4y plus 8z is equal to negative 14. And I'm going to add those together, and I get negative 3y plus 5z is equal to 9. Now I'm going to eliminate x out of using equation 2 and equation 3. So I'm going to go negative 6 times equation 2, and that gives me, that's a 2. So I get negative 6x minus 12y plus 24z is equal to negative 42. And then I'm going to add it to equation 3, which is 6x plus 3y minus 9z is equal to 15. And then I'm going to add them together, and I get negative 9y plus 15z is equal to negative 27. I'm going to call this one A, and I'm going to call this one B. And then I'm going to multiply A by negative 3 and add it to B so that I can eliminate my y's. And I get 9y minus 15z is equal to, oops, this should be a negative 9 here. Let me do a little erasing. Sorry, you're probably fretting about that. Equals positive 27. And I have negative 9y, this is equation B, plus 15z equals negative 27. And at this level, I get 0 equals 0. So this is infinite solutions and consistent dependent, right? All right, I'm going to do another video with just some more examples where you actually get a solution, just so that you can have a little bit of extra practice if you feel like you need it. Otherwise, these are what we'll be working on in class. Thanks. See you tomorrow.